Hello everyone. Today we are going to discuss the third application of dimensions, that is to deduce a relation among the given physical quantities. So let's start. We'll take an example to understand this, right? If a question says consider a simple pendulum having a bob attached to a string that oscillates under the action of force of gravity. Suppose that the period of oscillation of pendulum depends on mass of the bob, length of the pendulum, and acceleration due to gravity. Derive the expression for its time period. Right? So in this method, what do? We write the dependence of the quantity which we are deriving on the other quantities which are given in the question. So here time period depends on mass of the bomb. But how it depends? It may depend as a single part, 2 part, 3 part and so on. We don't know that. So we will write m to the power a. It depends on length of the pendulum. How it depends? We don't know. So we are writing some power for this. And on the acceleration due to gravity, again we don't know with what power it depends on this. Now combining these relations, we will write m to the power a, l to the power b and g to the power c. If we remove the proportionality sign, we can write a constant of proportionality and we can write this relation like this, right? So this is an important step which can be directly written instead of writing all these. So this is a very important step which can be marked as equation 1, right? And in this equation, the next step is writing dimensions on both sides. So for time period, the dimension is t. Constant, for constant there is no dimension, right? And for mass, the dimension is m. For length, the dimension is l. For gravitational acceleration, the dimension is lt minus 2. It is same as all the accelerations, right? So now what will be the next step? Collecting the dimensions of m, l and c and separating on both m, l and t on both the sides. So next step will be collecting the dimensions of m, l, t on both sides. Very important step. Here on left side we have m to the power 0 because there is no part containing mass. L to the power 0 but t to the power 1. On right side this is m to the power a, this is l to the power b and this is l to the power c. So we can simplify this further. M to the power A, L to the power B, L to the power C and T to the power minus 2C. So this L will be equal to B plus C, because if bases are same, exponents can be added. And next is T to the power minus 2C. What will be the next step? Next step will be comparing the powers of MLT on both sides to calculate A, B and C, right? So this will be 0 for M. If we are writing for M on left side, M to the power 0 and here M to the power A, so A becomes 0. For L, on left side it is 0, on right side it is B plus C. For T, on left side it is 1, on right side it is minus 2C, right? From here C comes out to be, we will mark these equations as 2, 3 and 4. So from here C is equal to minus 1 by 2, right? Let's mark this as 5. So put 5 in 3. What will we get? C is minus 1 by 2. So B is 1 by 2. Now this is 6. Put the values of A, B and C in 1. Next is put the values of A, B, C in 1. What will we get? T is equal to K M to the power A. A is how much? 0. L to the power B. B is how much? 1 by 2. G to the power C. C is how much? Minus 1 by 2. So you can leave your answer here also. But for further simplification, if you want, we can write it like this. L to the power 1 by 2 upon G to the power 1 by 2. And this can be written K under root of L upon G. So this is the required formula. So this way you can derive any formula. We'll take one more question here. Derive by the method of dimensions an expression for the volume of a liquid flowing out per second. Here in such questions, each and every word of the question is important because that gives us the correct dimension. So here what is given? We have to derive the formula of an expression for the volume of a liquid per second. Volume per second. Through a narrow pipe, assume that the rate of flow of liquid, that is, this is what? This is rate of flow of liquid now. And let's denote this by V. It is given that this depends on viscosity of the liquid. So this is proportional to viscosity. That means power, we don't know how it depends. We have to calculate that. And it depends on the radius of the pipe. But how it depends, we don't know. It depends on the pressure gradient along the pipe. So pressure gradient means pressure per unit length. So this is written as pressure gradient Gradient is change with distance. So this is to the power c, pressure gradient. We don't know how it depends, so that's why we have written this depends as power c. We can combine these three and we can write an expression eta to the power a, r to the power b, p upon l to the power c, right? And we can remove the proportionality sign to write it like this: eta to the power a, r to the power b, p upon l to the power c. Now writing the dimensions. Next step is writing the dimensions on both the sides. So next is writing dimensions. So in order to write the dimensions, we must know how to calculate the dimensions, because in some questions you will have to first calculate the dimension and then put in this formula. So writing dimensions on both sides. Now here, this is an important step. Why so? Because here V is not volume. It is volume per second. That is rate of flow of liquid. So what will be its dimension? Volume is L cube and upon time. So this is actually volume per second. So while writing dimensions, you have to be careful that you have to write L to the power 3 upon time here, right? Or directly you can write here L to the power 3 t minus 1, right? On right side there is no dimension for k, but for eta you know the dimensions for coefficient of viscosity we had calculated. So we can write it m L minus 1 t minus 1 to the power a. R is length because this is radius. This is to the power b. Pressure is force upon area. Force upon area is, we can calculate it, force upon area. So this is m L t minus 2 upon L2. So this is m L minus 1 t minus 2, right? So, or upon L. So this is m L minus 1 t minus 2 is pressure upon L. We can club these in the next step. L3 t minus 1 is equal to m to the power a we will not skip any step. This is m L minus 2 t minus 2 to the power c. So this will be L to the power 3 t minus 1 on left side, and this will be m to the power a L to the power minus a t to the power minus a. Here it is L to the power b. This is m to the power c, L to the power minus 2c and t to the power minus 2c. We'll collect these powers of m, L and t on both the sides, right? So comparing powers of m, L and t on both the sides. So for m, for L, for t, we'll calculate it. So for m on left side it is m to the power 0. So this is 0 is equal to a plus c. We can write this step again over here. This is m to the power a plus c, L to the power minus a plus b minus 2c. Now this is clear. We can rub this. and t to the power, here it is minus a, here it is minus 2c. So for m, left side it is 0 and on right side it is a plus c. For L, on left side it is 3, on right side it is minus a plus b minus 2c. For T, on left side we have minus 1, on right side we have minus a minus 2c. That gives us 1 is equal to a plus 2c. I can mark these equations 2, 3 and 4. We will solve these equations 2, 3, 4 for, so from 4 and 1. From 1 we can write a is equal to minus c, and if I put this value in 4, I'll get 1 is equal to minus c plus 2c. Therefore, c is equal to 1. Then I can put this value c over here again. I'll get a is equal to minus c, that means minus 1. So I've got two values, c is equal to 1 and a is equal to minus 1. And then I have to calculate b. So this is from 3. I can write 3 is equal to minus a, that means minus 1, minus plus b minus 2 into 1, because c is 1. So this comes out to be 3 is equal to 1 minus 2 plus b. That means this is minus 1 will go here, it will become 4. So this is 4 is equal to b. That means b is equal to 4. So let's mark this as 5, 6, 7. So from 5, 6, 7 in 1, what will we get? We get volume per second is equal to k r to the power b eta to the power a, that is minus 1, and p upon l to the power c, that is 1. So this comes out to be finally k p r4 by eta l, right? So this is the required expression, right? So this is how we solve such questions. That's all for now. Have a nice day.